So, parallelograms are by definition quadrilaterals with opposite sides parallel, or a single parallelogram is a quadrilateral with opposite sides parallel. So what that means is that we can draw on the parallel markings for each different kind of parallelogram. So we can draw on our arrows for this side and then the opposite side. And on the top, since this is not parallel to the left and the right side, we can draw two arrows to show that it's parallel to the bottom, but is not parallel to the left and the right. We could do the same thing with this parallelogram and with this parallelogram if we would like. So on our parallelogram on the left, which we call EHYP, or any other combination of those letters in order, to name our four pairs of consecutive angles, we could name these as H and Y, angle H and angle Y, angle Y and angle P, angle P and angle E, and finally angle E and angle H. All the consecutive angles are saying is that they're two angles in a row. So H and Y are in a row, Y and P are in a row, P and E are in a row, and E and H are in a row. So those are our consecutive angles. Our opposite angles are the ones that are across from each other and do not share a side. So in this case, our two pairs of opposite angles would be angle H and angle P and angle E and angle Y. These are our two pairs of opposite angles. To draw in our diagonals, diagonals are line segments that connect our opposite angles. So in this case, angle E to angle Y would be segment EY, and angle H to angle P is segment HP. So these are now both drawn in. Within a parallelogram, it has certain properties. One property is that the opposite angles of a parallelogram are congruent, and that consecutive angles of a parallelogram are supplementary. The consecutive angles being supplementary is something we can get from consecutive interior angles. If you remember that from parallel lines, that's how we can say that the consecutive angles are supplementary. And then we've done a brief proof to prove that the opposite angles are congruent before, but we'll touch on that a little bit later. So the opposite sides of a parallelogram are also congruent. And the final property here is that the diagonals of a parallelogram, they bisect each other. So the next quadrilateral we're going to discuss is a trapezoid. Trapezoids are quadrilaterals with exactly one pair of parallel sides. In this case, looking at it, it's pretty clear to see it's the top and the bottom that are exactly one pair of parallel sides, and we're going to mark those as such. So consecutive angles here of a trapezoid are also supplementary. In this case, though, consecutive only means these two here that we could prove with consecutive interior angles, or these two that we could also prove with consecutive interior angles. So we also have a special case of trapezoids called the isosceles trapezoid. So again, I'm going to mark our two bases as parallel. So this base is parallel to that base. So the special case of the isosceles trapezoid is a trapezoid with congruent legs. Our legs are these pieces of the triangle that are not parallel to each other. So when this says that the base angles of an isosceles trapezoid, they are congruent. And if we would like to mark these up, we could say that this angle is congruent to that angle, and this angle at the top is congruent to our other angle at the top. The angles that share a base are congruent to each other. These, again, as we said above, these would be our consecutive angles. Those are supplementary. And the diagonals of an isosceles trapezoid are also congruent. And we could prove this congruency using CPCTC, which we will do later on. One last thing we have to cover here is the trapezoid mid-segment theorem. So the mid-segment of a trapezoid is the piece that connects the midpoints of the legs. So if this is the midpoint of that leg, connects to the midpoint of this leg, we would draw it in here. So the mid-segment of a trapezoid is related to each base and can be found using the following formula. The formula is M equals B1, which could be the length of one base, plus B2, which would be the length of the other base, divided by 2. So our mid-segment is the average of the length of the two bases.